All right, it's after 12 now. Welcome everyone to the Northeast Digestion Roundtable. This is the 18th quarterly meeting. It's informal, supposed to generate some discussion and help all of us who are operating these anaerobic digesters get through. I'd ask you to please mute if you're not speaking and use the chat at any time. Freely use the chat to submit questions or comments. But at the end, we will open this up for discussion. You can turn on your cameras and phones. Always looking for future topics. So if anyone has a suggestion, again, post it in the chat, send me an email. I am very interested in any topics you might be interested in hearing about. All right, so today, for today's session, this is a great story. This is, the story is do the right thing, even though it's hard. Collaborate with others, play well with others. You know, you can really do some great things. It's my pleasure today to introduce Sherry Cousins, who I've gotten to know better since working with Nedr. Sherry is on our board, but she's also the executive director of the Greater Lawrence Sanitary District for about the past 7 years. And this is a big one, you guys. It's 52 million gallons per day through there. And prior to that, she worked for about 15 years for the Charles River Pollution Control District. Still pretty good sized plant, almost 6 million gallons a day. And she served for 4 years as their executive director. And prior to that, she was in the private sector, you know, cut her teeth at CDM Smith there. She's a professional engineer. Her background, she has a BS in environmental engineering from Wentworth Institute of Technology. And then she got a master's in civil engineering from WPI. She's definitely a leader in this industry, very generous with her knowledge. And you're going to see now why this project won so many awards. And with that, I'd like to ask Sherry if you'd like to go ahead and share your screen. I do have your backup files, if that's not going to work. Okay, I'm gonna go ahead and mute myself and shut off my camera so we can, oh, what do you got there?
It's good, Janine?
Yep, very good. Thank you, Sherry. Take it away.
All right, Janine, thank you so much for the introduction. I also want to let everyone know that Ben Mosier, who was integral with this Organics Energy Project, is also with us today. He's the VP and manager of the Northeast group for CDM Smith. So Ben, thank you for being here today as well. This is just an aerial shot of the Greater Lawrence Sanitary District that I think it's a pretty plant. I don't know if everyone else thinks that, but. So today I'd like to discuss a few items with everyone, including just the background on GLSD so you can get a feel for the type of plant that we have. And then I'll get into the organics ban and why we actually embarked on a co-digestion project, which we call Organics to Energy. We'll go over the components of the project, some startup data, what we're monitoring for different lab tests, the costs and funding, and then just highlight some of the challenges and benefits of the project, and then open it up for some Q&A. So a little background about GLSD, and the picture on the right is our pumping station, which is about a half mile from the main plant. And I always find this interesting to show off. We have two 1250 horsepower motors and two 800. And it's actually, this is a little bit of a dated photo. We've added eddy current clutches to the two smaller pumps, but we have some really big pumps that bring the flow to our main treatment plant in North Andover. So we were formed by legislation through the state in 1968. We've been operational since 1977. And just as other districts are governed, we have a board of commissioners that represent the communities we serve, and depending on the population of the community, they have 1 up to 4 commissioners at this time, but for every 20,000 an additional population, they have another representative on the board. We are regulated by the federal and state government, just as every other treatment plant is. As Janine mentioned, we're a 52 MGD plant, and our peak wet weather flow capacity is a little over 135 now, but we're leaving it at that for now. And one other item that makes us special, I guess you could say, similar to what Deer Island does, is we have an on-site heat drying facility that was built in 2002 in conjunction with our digestion facility, and we produce a little over 5,000 tons per year of a fertilizer pellet. And John Kopek from Synagro is also on the line, so I'm glad to have you here too. And 100% of our pellets are considered Class A, exceptional quality, and sold to local farmers and landscapers. So just to show you where we are, in case people aren't familiar, as I said, we're located in North Andover, as the star indicates, and we service the cities of Lawrence and Methuen, as well as the towns of North Andover, where we are, in Andover, the eastern part of Dracut, the western part goes to the Lowell plant, and all of Salem, New Hampshire. And you can see the Merrimack River goes right through our service area, and that's where we discharge our final effluent. So here's a fairly new process flow diagram that was put together. And, you know, we're a typical treatment plant in many ways. Like I mentioned, we have our off-site pumping station. We're a little bit backwards in a way, but it seems to work. We actually do grit removal before screenings. Then we have circular primary clarifiers. We have, and this is how it stands right now. We've had many iterations of different methodologies here, but we have an anoxic selector, we have fine bubble aeration, final clarifiers, disinfection and dechlorination with sodium hypochlorite and sodium bisulfite. The solids off of the primary clarifier, as well as the waste activated sludges and the food waste, all go to different thickening processes, except for the food waste actually. The food waste goes in directly to the blend tank, to the digesters. And from the digesters, we'll get into more detail. That's where we collect the biogas and send it to our engines or over to the heat drying facility. We have ways of sending it to different places. We have on-site furnaces as well. After digestion, the digestate goes into underground storage tanks. We further dewater and we send it over to Synagro, and they very nicely make the pellet for us. And Casella Organics works with the farmers to find outlets for that so we can recycle that material. So I just wanted to touch on this for a second because we've had an evolution here with how GLSD handles biosolids, and I just thought it was worth mentioning. So when we went online in '77, we took the waste activated sludge and primary sludge, thickened it, went right to the incinerator on site. So that was very convenient, I guess you could say. That didn't last for too long. Then we took the mix of waste activated sludge and primary sludges, went through gravity thickening still. And at that point we would decide, do we want to just go with a liquid offsite disposal or go through the belt filter press and produce a cake? Again, this is all landfill. It was during this time that GLSD realized this is not a sustainable model. We had trouble finding landfills that would accept the amount of biosolids we were producing. The costs were extremely volatile. And that was the impetus for GLSD to embark on the Anaerobic Digestion project, which went online in the early 2000s. And that's, like I mentioned, the heat drying facility and the anaerobic digestion facility went online a similar time frame. So from 2002 to 2016, before the Organics to Energy project went online, we were taking the waste in the primary, again, thickening it, sending that combination into the anaerobic digestion process, through the centrifuge, through thermal drying, and then beneficial reuse. So just worth noting, we've really been through a lot with our biosolids management and, you know, trying to continuously become more efficient with it. So as I mentioned, you know, we make this fertilizer product. It's branded under the EarthLife brand. Exceptional quality, over 5,000 tons per year. And it's a way of reducing the amount of commercial fertilizers that need to be used, along with many other things that I can mention further on in the presentation. So just to give everybody an idea of like how this all happened, I guess, I started as I took the director position in January 2014. And one of the first reports that I came across was this, actually, no, I'm getting ahead of myself. I'm sorry. Let me talk about the ban first. So Massachusetts had moved forward with an organics ban that became effective in 2014. And most of you probably are aware that the state is planning on going from producing 1 ton of food waste per week down to a half a ton. I believe it's this October, if they're on track with that. So anyone that's producing that amount of food waste or more can no longer dispose of that food waste at an incinerator or at a landfill. It needs to be diverted, recycled through composting or sent to an anaerobic digester. And this is impacting obviously larger facilities like hotels and restaurants and supermarkets. And the state's long-term target is 80% diversion. And I like to show, folks, this because, and probably most of you have seen this before, but I was intrigued when I saw this because although composting is an excellent way of recycling the food waste, EPA did put industrial uses ahead of it. And one of the items was fuel conversion and food scraps for digestion to recover energy. So I was really intrigued with that. Need to change something here. Okay. Let's see. And basically, anaerobic digestion is looked at as a twofer. We're able to recycle the food waste and also get the energy from it. This might be a little bit outdated. I can't be 100% sure, but it would be close if it's not exactly right. So in Massachusetts, out of 118 treatment facilities, 6 have digestion capabilities. The other one that's larger than GLSD is Deer Island. And this is good to know because all of these things came into play, should GLSD actually move forward with a co-digestion project or not. So as I had previously mentioned, I started here in 2014. One of the first reports I saw was this co-digestion feasibility study that was produced by CDM Smith and funded by the Clean Energy Center. And the outcome of this report stated that with Greater Lawrence's existing digestion facility, meaning 3 digesters that we currently have, that we could actually take in around 30 gallons a day of a source separated organic material. If we wanted to add a 4th digester, we could take around 90,000 gallons per day. And what was really intriguing to me was that if we went and added a 4th digester, that we had the potential to make all of our power needs, all of our electrical needs. And that would eliminate almost a $3 million electrical bill per year. And another thing that's really important to note here is at the time, GLSD had, and still does have 2 distinct power feeds into the plant, but we did not have full backup power via a generator. So this project, could also help with that situation as well. And the other item was that we would be an outlet for the food waste that the Commonwealth was pushing for. It's nice to divert the material, but you need a home for it. Another, huge incentive with moving forward on a project such as this is the biogas production. And, you're going to see for the same amount of gallons, 4 times the gas production. And that's, very important if you want to make a project like this financially feasible. This is a little bit redundant, but just another nice little process diagram of what co-digestion actually is. And I think most people on this call are probably very familiar with it. But GLSD already had the digestion complex, thickening capabilities, pelletizing capabilities, our, wastewater treatment facility, and producing a final effluent. But here, now we're going to add two other divisions, I guess you could say, where we're going to take in an organic waste, and we need to make sure it's pre-processed and, have minimal contaminants, and also, utilize the biogas in a different way. And this is actually probably a good time to mention that, for the last 10 or so years, before the Organics to Energy project came online, we were utilizing the biogas from the 3 digesters. We were sending that over to the heat drying facility, and that was the fuel source for providing the heat to dry the pellets. And we were also using it to heat the digesters and for furnaces on site. But obviously, taking on more biogas and using it for an energy, to produce energy, there was going to be a lot more that you would have to bring online to be able to use the biogas in that manner. So here's a nice photo of some existing and some new infrastructure that we've brought online. And I'll get into more details about each item in the subsequent slides, but you can see the 4 anaerobic digesters, the digestion facility, where B is labeled, you can see like a tall, thin flare, which is our existing flare, and the shorter one, which I was really surprised to see it, but it's a totally different design. Newer flare that actually has a higher capacity. Both are from Varick. Let's see, K and J are the vessels to reduce the H2S and siloxanes. Let's see, D is the radiators and chillers for the engines. And on the CHP building, which is H, on the top of the roof there, you can see the large units are actually HVAC units to keep this building cool, especially in the summer. And another thing that I found a little interesting about this project, the stacks are actually quite small. You can see the letter I is right over one of the stacks, and then there's a second one off to the left. E and F are where the offloading stations are for the food waste acceptance, and we have underground tanks for those. Like I said, I'll get into more detail. So we have 2 distinct truck offloading stations, and currently we use one at a time, but we do have the capability of using both. The receiving tanks, there's a picture before we put the cover over the underground tanks. We were actually able to place those adjacent to one of our underground tunnels. And in the next picture over to the right, you can see the tunnel, and it was wide enough that we were able to add not only the mixing pumps, but the transfer pumps for the food waste. Just a little more detail about the digesters. So the 4th digester we put in is almost a replicate of the original 3. Same volume, utilizes draft tube mixers, steel gas cover. It was determined through engineering analysis that we did not need to add a separate gas holding tank, that there was enough capacity underneath the covers that we could store enough, and especially where we were planning to basically burn the gas as it was being produced, that we wouldn't need a lot of storage in addition to the floating covers. Another item to note, CDM Smith did a really nice job when they designed the digestion complex originally in the late 90s, early 2000s, because they left space for the pumps and for the heat exchanger in case we wanted to add a 4th digester. So there was definitely some forward thinking there, and it was extremely helpful when we move forward with expanding that digestion system. The biogas conveyance and treatment system is state of the art. I don't think there's another facility in Massachusetts that's treating the biogas to the extent that we are. We have fixed media to reduce the H2S, and we're currently using a carbon type media for that, and we have 4 vessels. We also have a different type of carbon media for siloxane treatment. And the process has been working excellent to produce a very clean gas before it goes to our engines. We also have expanded gas conveyance capacity. So the original 3 digesters needed some modifications so they could overall, move more gas, because we were expecting to produce more gas once you start adding food waste. So that's been very helpful and has worked very well. And as I mentioned, we added a new flare, Mass DEP. Even though we had an existing flare, it wasn't the case that, oh, you just need to add another little flare, so between the two, it can handle the new maximum capacity. They wanted the new flare to be able to handle the entire maximum capacity of the new program. And so we did go ahead and do that. Here's a beautiful picture, at least I think it is, of one of our 2 Caterpillar engines. Each one is capable of producing 1.6 megawatts of power. We do have space for a 3rd engine if we want to go that route down the road. The regular mode of operation is that these generators are producing our base load here at the treatment plant, and whatever we have as extra is net metered onto the grid. We weren't able to send the power directly to our offsite pumping station because there are parcels in between our lot and the pumping station's lot, and the electrical utility would not allow that. So we found a way to be able to use this additional power, and what they let us do is net meter, and administratively we get credited kilowatt for kilowatt on that bill, which is very helpful financially. So at the plant, our typical usage is about 1,700 kilowatts, and at Riverside, it's about 1/3 of the overall 700 kilowatts, which we're at this point taking care of all of our plant needs and a portion of Riverside, but we're hoping as we come out of the COVID situation and more restaurants and colleges and universities and other institutions open up, that there'll be more food waste moving forward. Another really nice part of this project is the heat off the engine jacket and off the exhaust is captured, and we're using that throughout the plant and to heat the digesters. So not only are we using power from the gas, but we're using any excess heat to reduce our natural gas usage as well. I already touched on this a little bit, but I'm really proud of this. We have the best available control technology for the exhaust coming from both combined heat and power engines. And I did not mention their Caterpillar 3520Cs, and they actually are set up to run on biogas, but can also run on natural gas. So that's another nice feature of those. So we have 2 different technologies to clean the exhaust before it's emitted to the atmosphere. We have oxidation catalyst to remove VOC and carbon monoxide, and then we have selective catalytic reduction to remove NOx. And that system also requires a urea injection ahead of the SCR for NOx removal. So, expensive system, quite a bit of O&M involved with it, but we're really proud that overall it's an environmental benefit to have this system in place. So just going to fast forward a little bit, I guess, or maybe it's actually in the past, but one thing I should point out to everybody is when we decided to embark on this project, we planned on doing a pilot program and then a full scale. And as we were investigating sources of grants and loans and other ways to help fund this project, we realized that one of the biggest grant agencies at the time, Department of Energy Resources, had an incredible program in place at the time. It was a resiliency program, and they were allowing up to $5 million grants. The problem was they wanted this work done in a fairly short period of time. So when we initially asked for grant monies, they said, we can fund part of this, but we can't fund the whole thing because it's just going on too long. You can't do pilot. And then, they didn't come out and say it, but we basically were forced to condense the project and simultaneously do a pilot program and the full scale construction. And that's what we ended up doing. So we started with a pilot program in 2017, and we had a small pump in place at the time. We were using an existing mixed tank. We were taking in small amounts of food waste from waste management and slowly ramping it up until the full scale was available. And it was a chance for us to, fine tune what works, what doesn't work, determine the impacts on our existing digestion process. And at that point, we really started to monitor many different things much more frequently than we had in the past. So we were getting a lot of data to track and make sure that co-digestion was working for us. We were also keeping track of solids production, gas production, and the dewatering processes and thermal drying. One of the key ingredients for a co-digestion project is a source of food waste, which we call engineered bioslurry. And so GLSD embarked on a request for proposal process. We did get 3 different proposals. We evaluated all 3 and selected Waste Management. They in turn built a facility in Charlestown, Massachusetts, which they call CORE. And they take in the SSO material from all of the institutions we mentioned before and clean it, remove contamination, slurry it. They use complementary liquids to reduce the amount of water that needs to be added, and they produce this EBS product, which we've been very, very happy with. So there's one of the tanker trucks when we first started getting food waste, and they truck the material from Charlestown up to North Andover, and they offload and go back and grab another load for us and come back. So it's really working out very nicely. The pH of this engineered bioslurry is actually lower than I initially thought it would be. It's, let's say in the 4 range. TSS in the 9s, total solids can be 14, maybe a little higher. Volatile solids are very high, which is why you make, a tremendous amount of biogas from this material. Volatile solid to total solids, 85% or better. And a typical COD is about 270,000. So it's, very high COD, very high volatile solids, and, higher than typical solids of a municipal biosolid. So it is a different type of material to handle than municipal biosolids. Not that it's a bad thing, just we need very particular type of flow metering devices. A flow meter that works on municipal biosolids will not necessarily work well for measuring food. So, we learned a few lessons with that, but we did figure it out. Just a few numbers regarding our co-digestion, our performance before co-digestion. We're sending between 160 and 170,000 gallons per day of municipal biosolids to the digestion complex, about 4% solids, 2% in the digestate. Volatile solids reduction was about 64%. They around 50% for overall solids reduction. Our detention time was a little over 18 days, and our biogas production before co-digestion, 41 here that was a number when we averaged some data, but I would say between 300 and 450,000 cubic feet per day. So for folks that like graphs, and I'm sure we have a few on the line that do, I'm going to make you happy for the next few slides. So this is showing the startup of SSO feed starting in February 2017 through the end of 18. So this was startup, but you can see as soon as we started, okay. So this is basically showing how it slowly ramped up over time until we got to full scale. And I guess what's important to note here is our volatile solids, pounds of volatile solids per cubic foot per day before co-digestion was 0.12, and during the pilot we were at 0.19. So we were really loading these digesters quite a bit more than typical, but they were doing really well. Biogas production, this is a 7-day moving average. So we're showing a span of time before we started taking the SSO, which was, like I said, February of 2017. And you can see that as soon as we started taking in the SSO, the gas production went up, and it sort of mirrors each other. Someone's probably going to ask me what that big spike is around June of 18. I cannot exactly explain that, other than there must have been some type of a metering error, which happens sometimes with these flow meters. Again, when you embark on this type of project, you're going to keep a very close eye on how your digesters are doing with the addition of the food product. And, we found very stable pH throughout our pilot program and to present as well. In healthy ranges between 6.8 and 7.8. The volatile acid to alkalinity ratio, again, it stayed, fairly consistent. It was below the 0.35, which seems to be the number you want to stay below. And again, we felt very comfortable with the numbers that we were seeing, and we continue to see. So this is an interesting slide for food waste addition and biogas production. This is for 2020. And again, you can see it basically just mirrors each other. And that's basically what you would expect. And I guess what would be important to note here is, actually, we dipped a little bit there, but we're back into the 900 to a million cubic feet per day now. And this is just another slide for electrical production and export. So the orange is showing how much we're exporting onto the grid, which is used for the bill at the pumping station. And the blue line is our electrical output from the generators on site. And the gray is what we're actually using on site. So this is a really nice slide that really breaks down the power, heat recovery, and biogas for this new facility. And when we looked at the data, we found that we were producing about 1,900 kilowatts of power on average. And obviously that is contingent on how much biogas we're making. So the more biogas we make, we can run one or both engines, 50% or higher. These engines want to run at higher percentages, closer to 100%, the better. And we're using about 1,500 kilowatts on site, and the additional 400 is sent to the grid for the pumping station. And on a typical day, we're using about 65% of the biogas within the CHP process in the engines. About 25% is going to the pelletizing plant, and about 10% is going to boilers for heating and in hot water. And on a typical day, we are not flaring any biogas. And the heat recovery is about 4 MMBTU per hour. So I'm sure folks are interested in finding out, well, how much did this project cost? There seems to be a lot of components and a lot of big pieces. The overall cost was about 28 million, which is a large number, but I do want to let folks know that this project didn't just include items necessary for co-digestion, but also included major upgrades to our electrical systems coming into the plant, and transformers, switch gear. I mean, we basically replaced all of the original switch gear from the 70s. So it was an improvement that had to be done whether or not we move forward with this co-digestion. So it was done simultaneously. Where we really did well, grants and incentives, the Mass Clean Energy Center, who had originally funded the feasibility study, also helped us fund this project. They provided 400,000. DEP provided $500,000. Mass Department of Energy Resources, $5 million. National Grid's CHP incentive program was $2.34 million. And principal forgiveness through the Clean Water Trust was almost $1.6 million. Because we do serve environmental justice communities. So all in all, almost 10 million in grants was taken off the total price, which was really fabulous. Just a little more information on the financial aspects, because obviously this is not a typical wastewater treatment plant project. You know, it wasn't mandated by a new NIPD's permit, or it wasn't needed, you know, like I mentioned, the, you know, new switch gear. This was something, you know, we really wanted to take on to partner with the Commonwealth and have an outlet for the food waste, and also to provide, you know, major resiliency improvements for the district. So looking at the finances on the revenue side, tipping fees for acceptance of the food material, also eligibility for alternative energy credits, renewable energy credits, and also clean peak credits, which is a newer credit that I believe first became available in 2020. Projects had to come online after 2019. So avoided costs, you know, reduction in electrical needs from the grid. And also this was a way of tempering volatile increases in electrical costs. I mentioned the grants and incentives that we received, which, you know, thank you to all of those agencies. Also costs, which, you know, are part of the project as well. We did have to take a loan for the balance of what the grantors, excuse me, did not provide. So on the capital side, you know, the SSO receiving facilities and the expansion of the existing digestion system, the biogas treatment, CHP facilities, and the state-of-the-art emissions control, we had to take a loan to take care of that. And then moving forward, the first bullet is increased dewatering and drying costs. What I'd like to point out regarding that item is initial engineering, I guess, projections were that we would produce quite a bit more biosolids from accepting the food waste than we're actually seeing. It's 10% or less overall, and it's not an exact number we can determine because, you know, we're taking in quite a bit of septage and other items that it's hard to say exactly if it is a 10%, is it 5%, but we're going to say 10% or less additional biosolids production with the food acceptance. Also ongoing CHP maintenance, not just for the engines themselves, but the gas treatment, the exhaust treatment. You know, I would say heavy O&M with those items to make sure everything's running well. Related, but a little bit unrelated, but I thought this group might be interested in this. EPA did a study of GLSD Co-Digestion project and how it compares to other ways of recycling food waste. And I actually was really surprised at like how well, I mean, I thought it would be better, but I didn't realize it would be this much better, how much better anaerobic digestion is compared to composting, landfilling, and actually waste to energy did show a slight like positive improvement for global warming potential. So, you know, I'm not going to go into that any deeper, but I thought this was like a really nice graph to show the different parameters, and, you know, the green dot being what is the total impact with global warming potential. Below the blue line is a positive, and if you're above the blue line, it's actually, there is a global warming potential to that mode of recycling of food. And they broke it down even further, and 6 out of 8 categories, believe it or not, GLSD anaerobic digestion was the best performing. And the 2 that we were not the best performer was water usage and eutrophication. And when they were writing this report, I did question the eutrophication because they really thought, because we're taking in so much organic material, that we're going to have a lot more phosphorus in side streams, and we're going to end up discharging more phosphorus. And we're just not seeing that. We're not seeing that at all. And also for water use, you know, once that was brought to light that, you know, this was the, you know, considered the worst performer for water use, we've made a market effort to reduce the amount of water that's being trucked from Charlestown up to GLSD. So, we're trying to send up a thicker product and do some dilution here on site, and that's helping with a reduction in trucking traffic. So we're doing our best to try to bring that bar down. Another nice little graph just shows CO2 emissions from different ways of recycling food waste. And again, the wastewater, and this is just in general, not for just GLSD, but the wastewater treatment plant hauling is considered the best, with lowest carbon dioxide equivalent emissions compared to the other alternatives. So that's really nice to see as well. So I just want to touch upon challenges of this project because there were many. As I mentioned before, trying to finance what I call an atypical wastewater project that's not pushed because of the NIPD's permit or not something that's required because it's failing or ready to fail was interesting. But we really ended up having some nice successes with that. Also, we encountered an issue with the net metering cap that we had to talk to legislators and have them increase the net metering cap so GLSD could net meter excess power to the grid. We had ongoing conversations, and we have an amendment to a host agreement with North Andover that outlines truck routes and the amount of trucks and the hours. North Andover was excellent to work with in this manner, and we have a really nice amendment in place. So there's agreement on how this moves forward. Securing feedstock, like I mentioned before, we've had an excellent relationship with Waste Management. They provide a steady stream of the engineered bioslurry. We did see a dip because of COVID, but that wasn't, the fault of Waste Management, and things have picked up quite a bit, and we're, I think, just about back to pre-COVID levels now. Permitting for this project was much more intense than I expected. We had looked at other facilities, for example, up in Maine that were doing CHP and some food waste acceptance, and we thought the permitting would be similar to what they went through, and it was not. So, as we went through that process, we realized that we were going to have to invest a lot more money in some capital for the gas treatment and the exhaust treatment, and we were able to make that work, but it was difficult at the time. For engine operations and maintenance, we also requested proposals and got several that we reviewed. NISCO was selected, and they have someone here 40 hours a week to watch these engines, to provide basic O&M services. Anything major, they have other people they can bring in to help, and we have our own staff here too that keep an eye on things and are learning from them. But we do have a firm that specializes in engine O&M, especially the Caterpillar, and I know they're familiar with GE as well. In market analysis, I mean, as we, as time goes on, more and more facilities go online. There are different types of digestion facilities. There are other depackaging plants opening up, and you just want to make sure you're able to always secure enough feedstock for your project. Just to touch upon the environmental benefits a little more, we're using biogas, which is 100% renewable. Department of Energy Resources provided data that this is a 20% reduction in greenhouse gas emissions from our facility, and it's like taking over 1,000 cars off the road. Also, I touched upon it earlier that if we lose our power feed, that we can actually black start and start up these engines and power our whole plant completely disconnected from the grid, which is just amazing in my opinion. Let's see, and that's a picture of one of the CAT engines out in Indiana, I believe, when it was being tested out there before it was shipped to the district. A couple more project highlights, over 27 million invested in this new, in our facility, almost 10 million in financial assistance. It's providing a net economic benefit to the district, especially, environmental justice communities, advancing recycling of organics in Massachusetts to meet their goals. We're working to become a net zero or net positive electrical energy user, and I think we're getting pretty close. And, we've we've had several other projects in the past to reduce our energy usage and other renewable energy sources. And I feel like this furthers GLSD's tradition of innovation and we call the goal of net zero operation. So, really excited about this project, and it's been online since December of 2019, working great, happy to talk about it. And our project partners, CDM Smith, the designers, Methuen Construction, the contractor, Waste Management provides our food waste, and then the funding agencies, DOER, Mass DEP, CEC, and National Grid. And I guess open it up for questions.
Thank you, Sherry. Yeah, that was, again, a great story. I will go ahead and welcome folks. We'll have to take turns somehow with questions, but if you have some, you can go ahead and unmute and turn your camera off, and I'll try to moderate these. I have one if no one else. Isaiah, did you have a question? Well, I'll start, Sherry. So as far as like your return on investment, the payoff for this and rate impacts, can you speak a little bit to that? How many years before this kind of pays for itself? And how are you paying for? What is the rate impacts for this?
So we are not increasing GLSD is a little bit different than a non-district treatment facility. We actually have to stay within Proposition 2.5. Oh yeah. We have very strict guidelines for how we can increase, and we're not increasing costs to the communities for this project because the environmental credits that we receive, the tipping fees, the avoided electrical is paying for the loan payment plus.
Wow.
So we're not, in my opinion, there's no negative impact on the budget because of this project.
Wow.
For return on investment, I think you'll have to ask me that in a little bit because I need a little more data. And as most of you probably know, the value of different environmental credits varies significantly. So year to year it can change, and I know there's a lot of changes happening with that, and oversupply of certain types of credits really drives the price down.
Yeah, and actually, have you encountered any issues with, I know in California, there's a debate going on with these renewable credits. And when you co-mix food waste, which has a very high value, I guess, with biosolids, it dilutes the value. Is that the case in Massachusetts?
I don't think there's anything regarding municipal biosolids and food. What I do think is a distinguishing factor is the alternative energy credits are earned whether you're burning natural gas, biogas. It's basically an incentive for folks that make their own power. Now, the renewable energy credit, you only receive credits when you're burning biogas because you're using a renewable fuel source. So if you have a natural gas powered CHP, you can get AICs, but you're not going to get RECs, as far as I'm aware.
There is a question here about, is the Black Start capability using only biogas?
So Black Start is actually on natural gas.
But if you were to lose power, how long could the facility operate without national grid power?
I don't want to find out the answer to that.
I know you don't, Bob. I'm just curious.
Let's make that really clear. But we have exercised these units and we've disconnected, gone into Black Start, so we can train our staff in case we need to actually do that. If we're running on natural gas, it's indefinite. Yeah. I mean, in one instance, we ran for 5 days when the utility was doing some work. So we wanted to stay disconnected. And so we ran at least 5 days, but I think we could go a lot longer than that if we needed to.
Wow, that's very comforting.
Yes, it is.
Hey, Sherry, great to see you. Thanks for this. I had a question about the Mass DOER assessment on the greenhouse gas footprint, and curious if there's a report that we could reference, or if you could put us in touch with someone there. New York State is working on how they think about biogas, and we're facing a bit of a uphill battle, so to speak, with our legislature and our policymakers on whether or not biogas is renewable. So anything you can share with us would be
okay. I mean, the gentleman that projected those numbers retired, but I can find, emails that he had sent about it and the justification for, how he came up with that. So I will make a note and I will get that to you. Not a problem.
Thank you.
Good luck, Jennifer. All right, here's another question in the chat. Do you know if fog is blended into the ESB and how fog is accepted? I guess that's your contract there with.
Right, we have a specification and we have a contract with Waste Management as well. And we do not allow large quantities of fog to be, mixed with the food. It can be a certain percent, but it's not a large percent. I can't remember the number off the top of my head, but it, some fog, but it's still a minimal fraction.
And that's limited through your contract with them.
Contract, yeah, exactly. Mm-hmm.
Do you take any of that at the facility? Or what do you do with what you find in the collection system?
Actually, that hasn't really been an issue for us. We have about 9 miles of very large diameter interceptors, and we don't find a lot of fog issues there. Ben, if there's anything you want to chime in, I want you to be able to talk to about.
You're doing great. No comments.
All right, any other questions? Folks, you can unmute or somebody has.
Well, I'll keep talking. I mean, we've had the same problem with the pandemic and food waste going down. Ours isn't coming back as quick, but I'm curious if so is most of it, as far as you know, coming from commercial sources? And is there any move to get like residential food scraps, either from the GLSD area or other places into the system?
I don't know the exact answer. I think a lot of the food comes from food processors and some commercial. Regarding residential, I know Cambridge has a very innovative program for residential curbside pickup. Other communities are starting to get on board with that. I believe Hamilton, Mass. Now, the fact that we need to pre-process this material because it inherently has contamination, because folks will throw their paper plate and their fork and some other things will end up in the food waste collection. It seems to make more sense at this time that the food waste is being collected in the Metro Boston area because that's where the core facility is. But, let's see what the future holds, and, if other methods come up that we can start collecting more around here, that might happen. I'm not sure.
It might be interesting, Jennifer, to get who's your contract with again? Waste Management?
Same team.
Yeah. No, it might be interesting to get their perspective on how they're.
Well, we were getting residential brown bin program, kind of like Cambridge's program. We had a brown bin program in New York, but it was canceled because of the pandemic. So that's been part of our challenge, is kind of thinking about that and curious what others are seeing and doing in that space. So
that was a significant source for you? The residents?
Well, residents in schools were about half, because the way waste is collected in New York, the sanitation agency does residents and like city buildings, and then all commercial waste is separate by like the private sector. Oh. So we had like a mix, but we lost most of the city source because of the pandemic.
Oh, wow. Yeah, I'm not sure why there's a difference, but we are seeing a pretty good recovery now. Yeah, I hope the
great.
same goes for you. I'm not sure why.
Oh, I hope the same goes for everyone. I want to go back out and eat again.
Me too.
I'll contribute to the
I will
food.
chime in on that, Sherry. It was very interesting, the chart you pulled up, but we didn't spend a ton of time on it. But the biogas production in late March, early April 2020, literally was cut in half over the span of like 2 to 3 weeks, just based on waste availability. It was just very interesting to see the numbers.
Yeah, that was a tough time. That was a really tough time, just in general, for life, and then having that happen too. But
Yeah, I guess so. All right, anyone else have any other questions? We do have a few more minutes. We can chat. We can try to stump Sherry. I don't think you will, but well, let me just take the opportunity with somebody else.
oh, I just see that someone mentioned Cambridge residential collection came through CORE. Yes, that is true. Cambridge's, I believe, Save That Stuff is also involved with Cambridge's residential collection. But I do believe, I'm not saying all of Cambridge's food waste, but I think if not all, the majority of it does go to CORE. Yeah.
Which goes to waste management, which may end up there.
Yeah.
All right. Well, let me just take the opportunity again to thank you, Sherry, very much for sharing with all of us today. We did record this, and I'm going to post the recording in the slide deck on the Nedr webpage there. I'll shoot you an email with the link so you have that. And feel free to share with anyone. And if anyone has any ideas for future topics, things you'd like to hear about, I'm happy to arrange it. Just shoot me an email or give me a call. I'm open to anything there. All right. Well, thanks, Sherry.
Thank you.
Really appreciate it. Thank you, everyone here for attending on a Friday afternoon, a beautiful Friday afternoon.
That's a good point.
I hope you enjoy the rest of your day.
Bye, everyone. Thank you.
Bye. Take care.
Take care.